All right, welcome back. We are Game 3001 in the summer 2020 semester, and it's week 8, part 2 of our broadcast. It's the lab on line of sight is what I'm going to call it, is what I'm going to be doing. And here we're starting off with, we talked about decision trees today, and we're going to continue talking about decision trees. But the first thing I'm going to start off with is let's talk about that assignment a little bit. So I've got 2 assignments that we're going to be talking about, and they go for the people who were here earlier today. It's going to be a slightly different order, of course, than what I talked about before, because a little bit more organized in terms of what we're going to be talking about first. So let's go into assignment number 3. So in assignment number 3, I talked about this earlier today. We're going to have a bunch of requirements, right? And one of the things I want to talk about today with you is how can we set those requirements up. And the main requirement that I want to talk about is line of sight. I think that's where I'm going to go this week. So one of the things is we are going to be using a template to make all this go. And I'm going to be talking about this in a second. But before we download any template or do any kind of coding, I want to start doing a little bit of planning, because planning is the first part of what we do before we code. So here we have Sketchbook Pro. I'm just going to use, just going to make a screen like, kind of sketch. So here is our screen. So we're going to make a screen, and suppose this is your your screen that you're going to be doing for assignment number 3 and 4. So what I've asked for us to do is we're going to go through each of the requirements, and I'm going to start sketching out what your requirements are before we code. So first things first. So let's do this. And I'm going to do this a little faster than I did in the first lab, because I kind of went through, we had a bit of a discussion and so on with the first class. So again, if you see what it says for decision making, it can be up to 2 people. We talked about this earlier. And the first requirement is a start scene, which is mandatory. Okay, so now this is a great place to download the template. So my recommendation to you guys is, if you look at the template that's online, and I've put this link up on Blackboard. The template is SDL Engine, right? That's the template we're using. And if you notice on the right, there's a release number 21, version .21. So version .21, you can download it from here, which I've already done. I've already downloaded it in my downloads folder, but I'd ask you guys to do that. So the link for this, like I said, is on Blackboard. So if you go to Blackboard, and if you look at week 8, the link for this thing is going to happen as an example right here. So SDL Engine, you can go there and download that link. That's where I'm going to be using. It's almost like an assignment framework that I'm going to be using for the remainder of semester. I'm going to be using this thing. I'm not going to really update that or anything like that at this point. Instead, what I'm going to be doing is near the end of semester and before next semester, I'm going to update this thing to the newest version. And we do have some changes that we're going to be incorporating. But for now, what I'd ask you to do is just go to this link on Blackboard, SDL Engine, which will take you to the link on github.com/George Brown College, SDL Engine, releases 0.21, this one. That's the link. And then you'll be downloading the zip file. Okay? So when the zip file downloads, then you're going to go to, under downloads, here's downloads. I've got my SDL Engine 0.21 downloaded. I'm going to copy this, and I'm going to go to my desktop and paste it. Again, for those people just joining, I'm just downloading the the engine from GitHub. Okay. So again, what I did was I went to github.com /George Brown College. I searched for SDL Engine, and under there on the right hand side there is releases. I clicked on release number 0.21 and downloaded the source code. That's all I've done. And that went into my the downloads folder, where I got an SDL Engine version 0.21. I copied this one onto my desktop right here. I'm not sure why it didn't show my screen for a second, but here's my SDL Engine 0.21, and I'm just going to rename this to something that's compatible with what we're doing today. All right, so again, I'm just going to rename this thing so it says GAME3001 in the summer 2020 semester, and it's lesson 8, part 2, which is lab B. You guys are the lab B team. I think I did lab 1. Make this lab 2. There we go. Lab 2. Okay, so this is lab 2, and that's all I've done. So I just downloaded the template. And again, you can get that template either on Blackboard, SDL Engine, that'll actually give you the download link, or you can go to GitHub. Okay? So I'm going to run this thing. I'm running the template, and when you run the template, please use Visual Studio 2019. That's the one I'm going to be using for this semester, this year actually, chances are. And hopefully in 2021 they'll come up with a new version of Visual Studio, like they do every couple of years. And what I want to do immediately is do two things. One is I want to change from debug x64 to debug x86. And I'm going to go to my Solution Explorer. And when this finishes loading, it's not quite finished loading yet. It's going to be a second. I'm going to right click on my solution, and I'm going to say retarget solution. Right? So I'm going to retarget my solution for my Windows SDK that I have on my system. Press OK. And what this is going to do is going to make it compatible for sure with my system. Now I know it's compatible, but I'm telling you this is what I want you to do when you download the template. Okay, are you with me? Have you gone and downloaded the template and made it x86 and you know, done the retargeting solution thing? I'm going to see some for the people that are here. If you have, check mark. If you haven't, X please, and I'll wait for you. And then try running it. So if you run the code, thank you for your feedback. If you run the code, then what you're going to see is it's going to just build it back up. So we're going to build and run. It's going to build up that hidden .vs folder. And we're also going to see part of the template that we're going to be using today. It takes a second for it to build and run. Again, I mean, I have a pretty good system, and it takes long. So I have a again, an Alienware laptop that I'm running this thing with. It's an i9, 32 gigs of RAM, and I've got a pretty good video card too, so my system is pretty good in terms of performance, and it doesn't really matter. I mean, if I had the new one of the new AMD Threadrippers, then building and doing this kind of work would be quicker, but you know, it is what it is. So for you, it might take this long as well. But what it's doing, it's building back up all of its debug, you know, symbols and everything else for it to run, and that's why it takes so long. And creating the template.exe takes a second. All right, so you can see the start scene is this, and this is good, right? So we have a label, a couple of labels, a little image, and a button. And if you look at the requirements, one thing that I ask you to do in your assignment 3 is your assignment must include a start scene. Check. You have to add text labels to the scene. I have one. Check. With your name and student ID. So you have to just change the labels that I have already there to name and student ID. Check. Add a button to the start scene. When the start button is clicked, the start scene will transition to the play scene. Check. I've given you these 5 points for practically for free, right? Like you've got all this right here, right? Because I got a couple of labels. You can just rename these labels, your name and your student ID, and you get a start button. Done. I mean, really, that's how easy it is. I would like it if it was nicer than this, but this meets requirements, right? If I click start, it's going to take me to my little scene here. Now this all has to change, right? I have a couple buttons, a back button that takes me back and forth, right? I can go to my end scene and I can go back to my start scene. I have right now animation support, no movement support right now for my little Mega Man. I can go to the right and to the left. And one thing I can do is I also have a controller support. So I've just plugged in my controller and here's controller added. You can see that the controller is added in there, and I can go to the right and to the left with my controller. And if I unplug my controller, and again, I'd have to take the battery out. I take my battery out of my controller, then it says controller removed. So controller removed, controller added. It does that pretty dynamically, right? You know, so I can still go left and right with my keyboard, and if I add it in again by turning on my Xbox controller, you're going to see that a controller added again, and I can move left and right. So pretty dynamic controller support, I think, for one controller. You know, so you don't have to work so hard to get that going. That's all built into the framework that we've kind of created together. So if you look back at this, this part is practically done for you starting off. So this is a good base. Next, the play scene will demonstrate decision making. You must include a node class as discussed in class. What node class does this mean? There's multiple node classes that we can use. There's two types. One is the map node that we're going to be talking about in a second. And the second thing is a node, a tree node that we're going to be using. So there's two different nodes that I've talked about. You know, one of them that I talked about today, and I'm going to talk about the map node in a second. It says you must create a collection of node pointers to enable iteration across all nodes. This could be an STL vector, list, or other structure. Okay, that means this is the tree node. That's what this means. Ensure you select an appropriate actor sprite. This could be a spaceship, a car, blah, blah, blah. I'm going to use Mega Man for me. And he should be able to move with WASD, or the left stick on the gamepad should move him around. Depending on where I'm pushing him, he's going to move in that direction. Okay. And then I want to create an interesting map that is overlaid on top of the nodes. Okay, that's interesting. So there's nodes, node, and you know, tree node is, you know, kind of what I'm talking about. And what does this mean anyway? So going back to this, again, from a planning perspective, this is what we have so far. And imagine that I have a bunch of these nodes, and they're going to be display objects, right, or game objects as an example, but they're not going to have any update. There's three types of game objects we've talked about in game fundamentals. The first one is an object that displays but doesn't update, an object that updates but doesn't display, and an object that displays and updates. So this is the one that's going to be updating but not displaying. So let's suppose there's an invisible object that has a transform that gives you a position, and I'm going to make these nodes kind of around the map, right? Because one of the things I'm going to ask you to do is have our little enemy move around the map. I'm going to save this map when we're done at the end on Blackboard. So you're going to have almost like a patrol path, right? Where I might have a series of nodes here. Again, I'm just drawing them, but what you'd probably want to do is, you know, you probably want to set this out on your map a little bit more strategically than this, right? So I can kind of patrol around the edges of the map. That's one of the things I've asked to do. I probably also want to be able to travel inside the map. I'm just going to add some additional nodes in here so I can kind of move inside the map in different places. Maybe I want to be able to go in the middle of these, you know, as an example. So I can move any one of these places inside the map. I'm just going to put some random nodes here. And these nodes are the place that the enemy can travel to by having a destination to go to. And there's going to be more of these. So nodes. And nodes would be just like, again, if you think about a node having is just a game object, so it's not a display object. It's not going to be added to the display list. It's just going to be have a position. So a transform position is all it needs. Okay, so game object that does not display. Let's go back to this. So that is what nodes are. And it says create an interesting map, right? So this means make a map overlaid on top of these invisible nodes, right? And this can be a bit creative. Ensure the map includes obstacles, mountains, walls, whatever, that are impassable. And you may use a tile map set or simply draw your map tiles individually. It's up to you. Okay. The play scene must include appropriate background music and sound effects. I'm not going to go into that too much today, but you need to have all those things in place. And then we have a set of requirements. One, it'll set up all the key elements that will be reused in assignment 4. These include line of sight, detection radius, player movement, enemy movement, and others. Okay. A debug view, which allows us to see line of sight rays. You see line of sight is talked about again, second time. The detection radius, a collider boundary, and blah, blah, blah. And then some kind of debug keys that can, K, the enemy will take damage. P is the, again, the P key is pressed. The base enemy's movement will be toggled between idle and patrol. I can turn off and on the enemy so I can move around, that kind of stuff. And the user will be able to trigger various animations and blah, blah, blah. Okay? So player combat, the player can go into combat and all that kind of stuff. A player will have a health bar. Okay, let's draw the player. So first of all, we have to have a reasonable actor sprite that can move around, get into close combat, and have a health bar. So let's do that stuff inside of this drawing area. So let's suppose I want to put the player somewhere down in here. And let's make the player color a different color. Let's make it green. All right, so I want to put the player kind of in there. Okay, player. And the player also has a health bar. So the player is going to have a health bar, and so is the enemy. So let's just make the health bar black for now. So we'll say the health bar is going to look something like this. And we're going to also do some color for the health bar. It's going to have some kind of health area in here, right? That's where the health is going to be, right? And maybe make that bucket green in there so we can see that the health bar is green, right? And forgive me, it's crude, but it is what it is. Okay, and then let's copy it. So I'm going to go here and we'll grab that health bar like so. And we'll copy that health bar kind of on top of the player. So this is the player object, right? And we can also label the player object. Okay. Remember these nodes, these little blue rectangles or whatever, they're all invisible in kind of on the screen. You can't see these things. Okay, they're overlaid with a nice map, but you have these like movement nodes more than anything else. Okay, so that's what the player is looking like, and he's got a little health bar. Cool. Okay, let's go back to that. So it says, okay, the player has a health bar. Game status, your player scene will include a progress bar, score label, or other control. Let's make it just a label. So I have a label that says, what does it say there? It says that display how many enemies are still alive, still active. So active enemies, and then let's say we have 1, or let's say we have 4 active enemies. That'll be the total number. All right, I'm mismaking this up. So again, it'd be somewhere on the top of your screen. I'm putting it up here. Okay, active enemies 4. Yay. Okay, that part's done. Obstacles. Your play scene will include at least 4 obstacles. They could be the mountains that we talked about earlier. They could be other things. I'm just going to make some obstacles that are looking like platforms, okay, as an example, or something else. Okay, so 4 obstacles. Let's draw these obstacles, and we'll make them blue or some other color. So we'll make these obstacles a different color. Let's say orange. Orange is a nice, maybe a nice burnt orange or brownish orange color. And we'll make them various shapes. So let's say we'll make an obstacle that goes here. And we'll make an obstacle that goes here, almost like an area where the player is defended. An obstacle that goes here, and maybe another obstacle up here. Okay? So a few obstacles. There's at least 4 of them is what I've said, right? And we'll label them as obstacle. Probably should have done that first, but it's okay. So obstacle, there's another obstacle. And I think one of the things, guys, you might say, like, okay, why are we going through this? You know, it's kind of a waste. Well, it's not a waste, because what's happening is I'm literally planning assignment 3 with you, right? So this is part of the plan, right? You kind of come up with a plan of attack, if you will, when you make your game, and then you follow through. So there's obstacle. Hey, we'll make this obstacle like this, so we can save space. All right, so we got a few obstacles, or four obstacles here as an example. And what does it say? It says that 4 obstacles that will stop the player and the enemies from passing through them. And these obstacles must be solid and impassable. The obstacles will also block line of sight. Okay, line of sight again. Whoa, line of sight. How the heck do I do line of sight? And however, they will not block enemy detection radius. Ooh, what does this mean? Okay, well, let's make an enemy. So base enemy, you'll have a base enemy class. The base enemy will move or patrol along the predetermined path of nodes. Okay, let's make this base enemy. So we'll start the base enemy way over here at the other corner. Sorry. So let's make this base enemy a square, and we'll make it red so we can see what that looks like. Let's say we'll make the base enemy way over here. Okay, so I gotta fit in the thing, so maybe something like looks like this. And I want to make a copy. The base enemy is also going to have a health bar, I'm pretty sure. So let's make a copy of that health bar again. So and we'll copy and paste it above the base enemy. And you know what? I'm going to move all that down in a second because I think it's a little bit too tight. There we go. And let's just do that. Let's just get this out of here. And this time we'll cut this and we'll paste it, and we'll paste it a little bit down in here. Just give myself a little bit more room. And then we will name this base enemy. By the way, some people were confused with the keyword base, and it means like an enemy superclass or an enemy, an enemy class that other enemy classes derive from. Okay, an abstract enemy class is what it's going to end up being later on. But the base enemy is something that other enemies are going to have, and we talked about that for example, inside of your assignment 4, it says, hey, now we're going to extend the base enemy class, and we're going to make it enemies that are close combat enemy and a ranged enemy, right? So that's the base enemy right now. Okay, and it says here that the base enemy class will move patrol around the predetermined path of nodes. That means it's going to move around here, maybe around the edges. And the base enemy game object will have health property, which we displayed in a health bar. We just took care of that. When the enemy game object is hit with the health bar, we'll display the correct value. Yay! Or when you press the debug key. That's what we're also getting it to do. And the base enemy is also going to have some animations and sound effects, which is mandatory. And the base enemy is also going to have line of sight, which is mandatory. I want to cover this one today. It will need to calculate and keep track of whether or not they have line of sight with the player. So it's like I want to cast a ray. Okay, like we're not quite doing ray casting, but it is like that. And I want to cast a ray, and I want to make this ray for now red. Let's keep it red for the enemy. Again, it'll be a debug color like green eventually, but for now it's going to be a red ray. Okay, so if I cast a ray, let's say approximately from the middle of the enemy to the middle of the player, right? Let's do it from this corner for now. And let's use a straight line as opposed to that really weird wiggly one that I forgot to turn on. And the question would be to you, do I have line of sight? And the answer should be no. Why? I'm passing through this obstacle. And if I'm colliding with any obstacle between the time I'm from this line all the way to this line right here, to this, from this position to this position, then I do not have line of sight. Okay, this is your sight line, okay, that you're going to be casting. So that's something that the enemy, I'm going to have to calculate. Does the enemy have line of sight? Okay. So that's line of sight. And the other thing the enemy is going to have is something called detection radius. And the detection radius, a simple algorithm that determines if the player is within each enemy's detection radius, which can be a range of your choosing. Like the line of sight check, it can be stored as a Boolean and will be used for the next assignment. Cool. So I need to have those in place too. Let's make the radius a reasonable size. So I'm going to start with the middle of the enemy, and we'll make it so it's something like this. There's your radius, right? And let me undo that check for a second, and let me just get rid of this ugly thing right here because we don't need it anymore. So something that kind of goes like this, and maybe get rid of this, and right. Let's try that again. So and we're not going to do this. We're going to do this, and we're going to do this. So again, a reasonable size. So that would be a kind of a reasonable size for a radius. So you've got your radius. Call this almost like a detection radius, like a hearing radius or a smell radius or some other kind of life sensing or whatever that the base enemy has. Again, it's not a base enemy, like there's no enemy base. This is a base class, which is like a super class, as an example. Okay, that's what we're talking about, or a parent class, a parent enemy, or that kind of thing. That's why it's called base enemy. So that's it. That's the thing that we've been asked to do, right? So okay, and you just get in GitHub, blah blah blah. All right. So the obstacles, they will stop the player and enemies from passing through. These obstacles must be solid and impassable. The obstacles will also block enemy line of sight. Okay, block, but they will not block detection radius. Okay, cool. So there's a few scenarios here for our map. One of them, this is case 1, and we'll say that we have line of sight. We'll say is false. We'll use false this time instead of yes and no. And radius, we'll say is also false. So this is the first scenario where, in this particular case, my player is neither in the radius, as an example, so they're not in line of sight, and they're not in the radius. Okay, this is scenario number 1. Okay. Scenario number 2, okay, is, and I'm just going to use, this one right here. Scenario number 2 is where I have, let's see if I can capture this without capturing the line. I can. Scenario number 2 is where I have an enemy up here, right, let's say. So the enemies come closer to the player. And let's just draw the radius again. And I'm going to try and draw it approximately the same size again. So we'll say that it's like about this big, right? Let's make it a little bigger. Yeah, that's fine. And this is scenario 2. Sorry, let's suppose that the radius is the same size. Okay, but the player's in range. Okay, so let's actually undo that change, and we'll move that closer. How about that? Because we're saying that I want to be close. I'll make it closer there. I'll make it like much closer. So the enemy's on the other side of this obstacle, as an example. That's more reasonable. Sorry, because then someone's going to complain about it. They're going to like, wait, there's no collision. I don't understand. And they'd be right. So here, that's more reasonable. Okay. So in this case, this is scenario 2. So case 2, where the line of sight again is false, but our radius, that's true, right? They're in radius, but they're outside of line of sight. Okay, so that's kind of a scenario number 2. Okay. Why? Because there's no line of sight, because if I draw a sight line, so if I do from here and I kind of go, there's an obstacle in the way. So if I do one of these, you can see clearly that there's an obstacle between me and the player. Okay, obstacle. So there's no line of sight, but radius, player's in the radius. So player's been detected, but I don't know what line of sight is. Okay. And the next one would be another scenario. Let's do another one. So there's 4, right, total scenarios, and I'm sure you can divine what those are going to be. But let's try this out again. So we'll go and do one of these. So here's the next one. So line of sight, good. Let's say from over here. I'm guessing. So line of sight. Do we have line of sight? If not, we're going to have to redo this. So make sure that we're good. So line of sight is good, right? But enemy radius, no good, right? Because, you know, that is an option. That's a possibility too. So enemy radius, let's say approximately like that, no good. So this is the next scenario. So case 3, line of sight, true, right? But radius, false. Okay, so that is scenario 3. Okay. And the final case is where you have both. So again, I'm just going to go and grab all this stuff. And you're going to say like, Tom, I still don't understand why we have to go through all this. Because, you know, I'm telling you, it's going to help you with what you're going to do for this assignment and next. You're going to see a value. So now you have a situation like this. The enemy is over here. And this is a case where we have both. We have the enemy can draw a line to the player, right? And the enemy has, you know, it's inside the radius, right? So we have both things. Okay, so that's this scenario. So let's do case 4. We're going to say line of sight is true and radius also true. Okay. So that's pretty cool, right? There we go. Makes sense? Line of sight true. And so those are the 4 different scenarios. Now I've kind of gone about it in a weird way. I've said like this is scenario 1, 2, 3, 4. But I mean, you could have made any one. This could have been the first scenario, 2, 3, 4. Doesn't matter. But there's 4 different scenarios, and we need to account for all these different scenarios. So where we both have, so line of sight, two have line of sight, 2 don't, and 2 have radius, 2 don't. Okay, so that's how the you know, the scenarios are split up. So we've talked about the obstacles in line of sight, and this is great from a planning perspective. This is where we first start off. So line of sight seems to be an important thing, and so is radius check. Those 2 things. Today I'm going to focus on line of sight, how to get line of sight working. Okay, and maybe some player movement if we can later. That's part 1. But we also have to consider that after we do this, and this is our base for the assignment 3. This is really what assignment 3 is about, right? Assignment 4 is also going to creep quickly upon us, right? And for assignment 4, let's take a look at that really quickly. Because really, when we do our planning, we want to plan for both scenarios. We want to plan for assignment 3, and we also want to plan for assignment 4. Okay, so here is assignment 4. So we use assignment 3, mandatory, as a base. Okay, and then my game must also include the following A actions. Patrol. The enemy is going to patrol along a predetermined path of nodes. Cool. Move to player. Okay, requires line of sight. Look at that. Move toward the player using a rival steering behavior. So we're going to ask you to do some steering behaviors. Stop at close combat distance. Play the move animation and related sound effects. So move to player. Well, this is going to present the problem, right? Just moving to player is going to present the problem, because if you think about it, if I go back to my map, if I take this guy and I move him to the player, he's going to go right through the obstacle. So that is going to be an issue. Okay, so one thing is we're going to have to think about obstacle avoidance as I move towards the player. So the thing that you learned last semester about obstacle avoidance, we got to put together now. Obstacle avoidance. What else? The other thing that it talks about is a close combat attack. Okay, requires line of sight again. There's that line of sight. Close combat distance. So some kind of calculation to make sure that we're in range. Play the close combat attack animation and related sound effects and start damaging the player. Cool. Flee. Move away from the player, avoiding obstacles. There's that obstacle avoidance thing again. And leave the scene. Play the move animation and related sound effects. Cool. Move to line of sight. Okay, interesting. Find the closest node to the player with line of sight. Closest node to the player from where the enemy is. That's what this means. Use obstacle avoidance along the way and use the seek steering behavior to move. Play the move animation and related sound effects. So that means that if I go to this map again, what is the closest node right now that I have that has line of sight? Well, it could be this one. No. It could be this one. Maybe this one, right? So how do I find the closest node to line of sight? Well, that means that nodes themselves are going to have a line of sight, true or false, with the player constantly. And that's when I'm moving. When I have to gain line of sight or move to a node that has line of sight for the enemy, I got to turn that functionality on for these nodes. So not only does the enemy have to have line of sight lines, but so do all of these nodes at some point or another. And if that's true, that means that I have to draw sight lines. I'm not going to do a crazy map for a second, but I should draw sight lines as an example. Let's say from this node to the player. So the player, this is the first node that would have from this enemy that would have line of sight as an example, right? So I'm going to move to the closest one. Well, how do I move there? I could use arrival behavior, so I don't have to move across this. But what if there's an obstacle in the way, right? Like, for example, for this guy. The first node that has line of sight in this case right now, right? The first node is, the closest node is this one, okay? This one doesn't quite have line of sight, look, right? Doesn't have quite line of sight. So I'd have to move here somewhere, somehow, right? Here. And that's okay. But there might be a case where if I'm moving, I have to avoid the obstacle to get into line of sight. And that requires more nodes, my friends, more nodes to help us do that. Like, for example, and we're going to talk about that in a second. So that's one thing. The next one is move to range. Requires line of sight. Damn, everything requires line of sight in this game, right? Here's one that really requires line of sight. Move behind cover. Okay, this is a challenging one. People get confused on how to do this. Find the closest node to the enemy that does not have line of sight. Okay? And move there. Play the move animation and related sound effects. Whoa, wait a minute. So I got hit by a player. In the future, I'm going to be the ranged enemy. I need to find line of sight. I want to move behind cover. Yeah, no. So the smart thing to do is to build in some nodes. When you add in these obstacles, build in some nodes around the obstacles, so that way you can have multiple positions that have no line of sight. So again, going back to this, that means that each obstacle should at least have, let's say, I would build in something like this. I'm saying, let's say this node is part of this one. Okay, just because I don't want to clutter the screen too much, right? Something like this, right? Where you have some nodes around this obstacle, you have some nodes around this obstacle, and these are all, let's say, walkable nodes, okay? Nodes that the enemies can walk to, that provide, let's put that one there, provide either line of sight or no line of sight for the player and enemies, right? So you can see how I do this, right? Again, this is one possible solution. You could also use tiles as opposed to doing this, but our assignment clearly asks you to use nodes. Sure, that's okay. We'll put one there, maybe another one here, and another one there. Okay, and I think that covers all the obstacles. So you can see now that we have a more complex map. So that means if I needed to move to a position that doesn't have line of sight, well, it's not this one, it's not this one, it's not this one. This probably is a little bit further out. It's closer to the player. I'd have to move through the player. That's bad. I also have to do obstacle avoidance with the player because I'm moving away from the player. So I'm moving away from the player, but I'm also finding like some cover, which is probably over here, right? So not this one, because this one has line of sight. Probably not this one. The closest obstacle, the closest node would be this one, right? This one still has it, so this one or this one. These are the two that don't have line of sight. And you can clearly see that because if I draw a line from here to here, there's no line of sight, and there's probably no line of sight from here to there. Okay? So one of these two obstacles. And that's how you would create you would go hide behind cover. The nodes themselves would be intelligent enough, right, to indicate to the enemy which one that would not have line of sight. There would be almost like a list of nodes that didn't have line of sight. You could actually put all of these nodes in a list to give them either line of sight or no line of sight. And depending on if they didn't have line of sight, they would be in the no line of sight list. And you would know these nodes all have a transform position, and you could look at the position of the transform of each of these nodes and to know which one is closer to the base enemy, and that's where the enemy would move to gain cover. Okay, again using obstacle avoidance. And you could also use, to help with obstacle avoidance, you can also use the node path to get there. So a shortest path. So for example, it could move here, 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 and then there, right? And that would be the path to the shortest path between the enemy and the node that doesn't have line of sight. That could be the way that you move the base enemy. Or you can use feelers and some kind of sensing. So when the enemy is moving towards the obstacle, it would go around the obstacle by using some kind of sensing system to do it as well. One or the other. It doesn't matter however you do it, but you'd have to do something like this, okay, to move from one side to the other. And that's really your map, okay? That's really your map. That's really what you should plan on doing, this kind of thing, at the very minimum. And you're probably going to need more nodes than this because you want to kind of provide additional options for the enemy to move smoothly around obstacles. You may want to include additional nodes kind of in the middle, but not too many, because the more you add, then the more of line of sight calculations you're going to make. At some point you need to create a balance between kind of the enemies and the number of nodes that are on the screen. Okay, so this is kind of the plan that you're going to use for assignment 3 and 4. I'm going to store this thing on Blackboard now. So I'm going to say save as for you guys, and then we'll bring this up again next week. So I'll put this inside of our course shell for what we're talking about this week. So I'll save it for now, and we'll call this is an inheritance diagram. This is a we'll call this a plan for assignment 3 and 4. Assignment 3 and 4 plan. Okay, and I'll move that into darn, it's a TIFF, isn't it? Sorry. Save as. Let's try that again. And instead of a TIFF, which is pretty huge, we'll make it into a PNG. Okay. Otherwise, it's going to be a little bit big to put up on Blackboard, which is nothing what I want to do. Right. We'll actually build an item, and we'll put up that document, so you can always see it later. Is what I'm saying, right? That's the idea with it. And where is it? Here it is. Okay. So you should have that, and I wanted to. Oh yeah. Assignment 3 and 4 plan. We'll say it's a sketch. Okay, and we'll put that sketch up here for you guys right there. By the way, what I'm doing right now for the lab is streaming, and it's being saved on YouTube, so you can always go back and look at this later. But the sketch will be right here for you guys to look at. Cool. So questions around this? Do you agree? Do you think this is too much, not enough? What are your thoughts? Anyone have any thoughts you want to share on chat about this? Would you do this if you're going to make a game, or maybe something more detailed than this? What do you think? I'm not really seeing any feedback, so I'm just going to assume that this is okay. So yeah, so now we know that line of sight probably is central to what we're going to be doing with our game. We need to kind of code that, and that's the first thing I want to code with you guys today. How to do line of sight. Well, first we can look at our scene. Let's look at the anatomy of our scenes right now. So right now we have a couple of things. We have as we start the game off, Like we said before, we have a button that starts off our start scene. Here's our start scene. And we have a couple of buttons in the play scene. We don't need these buttons. Let's remove those right away. So we're going to go into scenes. Again, our structure of our project is like this. Core is where I have most of the core pieces of code. Again, I'm using my template. Alex's template is very similar to mine in terms of structure. He may have added some other things or called them different things, but at the end of the day, it's very similar. But inside of our scenes, we have a playscene.h and a playscene.cpp. I'm just going to go to the playscene.h first, and I'm going to remove the buttons from the playscene because we don't need them. So I'm going to go back down in here, and you can see that we have two buttons, a back button and an X button. We can move those out. And also what I have to say is as we move forward and continue coding, I also have to report to you that I'm using ReSharper C++. So ReSharper, under this extension, you can see that there's an extension that I'm using called ReSharper. From what you guys said last day, did I delete too much? I may have. Let me just undo that change. Why am I getting an error? From what when I talked to the first group today, they said they've never had ReSharper, and what I asked them to do, and I put a link here on Blackboard for how to get the free educational license for JetBrains products. The people who make ReSharper, which is a tool that you can use to code a lot better, easier with C++, I would say, and get really good tooling support, is JetBrains. These guys are awesome. Again, no affiliation with JetBrains, but the great thing about these guys is they have a ton of tools, some of them that you've probably heard about before. If you've ever done any kind of thought about programming an Android app, they have Android Studio. These guys make Android Studio. These guys also make other really cool tools. For example, they make IntelliJ IDEA for Java development, PHP Storm, WebStorm. They also have CLine, which is a C++ IDE. And again, WebStorm, I would say, is probably on par, if not better, than Visual Studio Code in terms of coding JavaScript and other products. And they have these tools, ReSharper C++ and ReSharper for C#, right? They have Rider that works great with the Unity game engine. And they have another tons of tools that they use for other things, right? Which is pretty cool. So lots and lots of stuff that these guys have, and you can get all these tools for free if you get an educational license. And the way to do that is to sign up, apply now for your educational license. I put the link on Blackboard, and you get access to ReSharper and all the tools that they have, as an example, for as long as you're a student, which is pretty cool at George Brown. Okay, so please, if you haven't a chance to do this, go and apply now, and then you can have access to the tools. And the way it works is you download and install ReSharper C++, and what ReSharper C++ does is it binds itself to Visual Studio 2019 as an extension, and then you get some really cool functionality from it, which I'm going to show you in a bit. All right, so we've removed the buttons, and I'm going to have an error now in my playscene.cpp. So if I go to my playscene.cpp, you're going to see a pile of errors show up here on the bar. Why? Because I've removed these things. So we need to get rid of any reference to the buttons. So I'm just going to get rid of those. And all these errors down here, these are all the buttons. I'm instantiating buttons. I'm getting rid of all these buttons down here. So no buttons. Buttons gone. All I have is the plane sprite and the player sprite. Okay. So I should be able to run this now, and I should have just my play scene with just the player sprite and the plane sprite, no buttons. Which means it'll disable the ability for us to get to the end scene, but that's okay. We don't need that for assignments 3 and 4. And again, it's going to take a moment for me to compile. I also have to say, if your compiler is faster than mine, great. If you're using a home system, it's probably going to be faster. Or if you're not streaming on YouTube, broadcasting on Zoom, and have 3 screens going on with a mic and a camera, right? Then all the power to you. All right, so yeah, start. So you can see the buttons are gone. I can still move around. Well, I can still animate around. I can't move yet. Cool. But in order for me to demonstrate line of sight, I need an obstacle, and I don't have an obstacle. So I'm going to create one really quickly. I'm going to use a program called Fireworks. It's an old program, but you can use any program you want. You can use, like I told you guys before, Krita, which is a free, kind of Photoshop-like tool that you can use. You can use Photoshop. You can use Illustrator. You can use a ton of tools that are out there that will enable you to do what I'm going to do right now, which is basically just make a very simple PNG image, a texture that I'm going to use. Okay, so I'm going to click New, and I'm going to make an obstacle that, let's say, is something like 100 high for now, and maybe 150 pixels wide. Let's see what that looks like. And if it's too much, like this looks like it's too much, I made it this big last time. I'm going to make it smaller this time. So again, you can do that by modifying the size. And I'm going to make the size, let's say 50 by 150, which is more reasonable. This is kind of like the obstacles that I drew in my drawing. In here, kind of like that. Maybe not this one. And what I can do is I can make it, I'm going to make it red. And I'm going to draw the obstacle like so. And let's make it so that it exactly fits onto my canvas here. So we're going to make it 50 by 150, starting at 0, 0. There we go. And let's make the border like 5, so it's nice and thick this time. And there we are. So something that looks like this. A red box with a black border. Yay! Excellent. What an obstacle. File. Save as. And we're going to go to the desktop. And I'm going to go to GAME3001 Lesson 8 Part 2. I'm going to go into Assets. I'm going to go into Textures. And I'm going to drop in this thing as obstacle.png. And just to make your life easier, I'll even, for this demonstration purpose, I'll put this up on GitHub. I'll put this up on Blackboard for you as well. If you want me to, if you don't want me to make the obstacle. So, item. We'll call this obstacle. Texture. Right? And we'll just get the obstacle texture from the desktop for you. There it is. Okay. Obstacle. And now you'll be able to follow along with me. It's a beautiful obstacle. I mean, it's red, right? So that's everything you need to get going this week so far. So I'll give you a sec to do that. So again, my project has it now. But what I need to do is inside of the code, I need to actually add an obstacle. So let's do that next. Now we got to figure what this is. There's a couple of, in core in our project, we have a couple of things here. We have a display object, right? And we have a sprite. We also have a UI control. UI controls are for buttons. We have 2 of those. We have a button and a label for UI controls. And we have a sprite for the plain sprite and the player. So the player itself under game objects, player.h, it derives from sprite, and so does the plain sprite. There's the plain sprite. Okay. But we also have another example called target, and target derives from display object. So I definitely want to make this a display object, but it doesn't have to be a sprite because it's not going to animate. So I think this is the closest thing that I want to use. So let's make a new one. So under game objects, I'm going to right click and I'm going to add a new item. So we're going to make the obstacle first, right? And it's going to go into the SRC folder. This is important to retarget where it's going. I'm going to make the .h first. I'm going to call this obstacle. Okay. And right away, let's make the .cpp as well. So add a new item, and I'm going to click CPP. It's going to the same place. Obstacle. Okay, so .h and .cpp. I'm going to make the .cpp file include the obstacle. Man, I can't wait till my new system comes. I'm actually building a new one so I can cope with all this load that I'm putting on. Okay, so here's this one, and then I'm going to say if not defined obstacle like we've done it in the past, then we want to define it. Okay, and end if. Okay, so that's this part. And what I want to do with the obstacle is I want to indicate that it's a class called obstacle that derives from or extends the public display object superclass. And you can see that it glows red because it doesn't know what display object is. And nicely, guess what? Resharp or C++ says, hey, you can include displayObject.h and it'll help you. So sure, I'll do that. I'll click on that link and then it'll include displayObject.h for me. Again, notice that I'm going to get help as much as possible from my tools, right? And then I'm going to make a public section and a private section for my my stuff. And up here, what I can do is, because I know it's deriving from display object, right? The class obstacle is also going to have some options. I can generate missing members, right? Which is part of, again, Resharp or C++. It's going to bring up a little dialog box that goes up like this. And it tells me I can generate draw, update, and clean, because draw, update, and clean comes from the display object superclass. I'm going to say finish. And what I also want to do is I want to generate my constructor and a destructor. And now that I have all this, I want to use ReSharper again to implement all these. So I can just click on one of them, go over here to the hammer, and then say generate. Actually, I go up here to the class, and I can go to the light bulb and say generate definitions by declarations, which is going to bring up another dialog box that's going to show me the constructor and destructor plus all the lifecycle functions, and it's going to generate those in the CPP file really quickly. And I'm going to go back to obstacle.h for a second and do a little bit of commenting. So I'm going to say that these are display object lifecycle functions. I call them lifecycle functions because they do what all display objects do: draw, update, and clean. Okay. But we need to define some stuff for the constructor. So I'm going to go to the definition of the constructor and add some common things in there that I always add in the constructors, which I'm going to call the texture manager. And notice it says, hey, include the texture manager. Yes, I do. I want to include it. Hey, texture manager, I want to not load sprite sheet, because load sprite sheet's more of a sprite thing. I'm going to load the file that I want. And again, I'm not going to guess what it is. I have an example in target.cpp. So you can see that it's assets, textures, and whatever it's called. So let's do that. So it's going to be from .assets, and then textures, and then the name of the file, obstacle.png. And then what I want to do after the file name, because see, the next part of the signature is the ID that I want to give it. And I want to give this an ID of obstacle. this is where what I want to store. The friendly name obstacle is what I'm going to use to store this texture inside of the texture map that's hidden inside Texture Manager. Okay. And by the way, if there's a problem, like for example, get instance or instance is what I'm missing here. And that's fine because Texture Manager is a singleton. I got to call its instance and then call the load function, and that would kind of suffice, right? So that's the first part. That's loading up the obstacle and storing it in the texture map. Okay, that's what it does. And then I want to do some of these other things. I'm just going to grab all this from target.cpp because it's going to be almost the same. And inside of my obstacle constructor, it's going to say, okay, I want to look at the size of obstacle, not circle. It's going to automatically set the width and the height based on the texture size. That's what it's going to do. And it's not colliding initially, no. Here's the default position. We're going to change this in a sec. And here's the type. Well, it's not a target, it's an obstacle. Let's right-click and go to definition. And under the definition, we have an enumeration, which is game object type. And if you look on the right there, what I have is inside of my project structure, there's an enums folder or filter. And there is a game object type enum right here. And that's what we're looking at right now. Now, notice that this type is not included. Let's just make one. We'll call this obstacle. Okay, so we have like ship, target, player, plane, whatever. But we also have obstacle. And so then we can set that here inside of the constructor. Okay. So the constructor, that's how it should look. Next, we have this thing glowing green. It means that, hey, by the way, Tom, maybe you can make this a default destructor. I agree, for now we should. So I'm just going to use this quick apply this fix for it. And the fix is going to make the destructor be a default destructor. I think it's a good fix. And then we have to set up the draw function. And we're going to still use the Texture Manager draw. So we're going to say something like, I want to draw the texture, but I need to draw it at the position that I set up for, which is the transform position. I want to draw this thing in the transform position, and I have an example of that in Target CPP, which looks like this. So I'm just going to grab these lines of code and drop it into my obstacle right here. But instead of me drawing a circle, I want to draw the obstacle in the right spot. And that's what this does. So now, obstacle done. Obstacle done. So again, here's the obstacle. For people who are watching the YouTube broadcast, there's the obstacle constructor, and there's the draw function, right, which we're going to call to draw the obstacle. Okay. By the way, these extra little marks here, ID, angle, alpha, centered, and all this kind of stuff, that comes from ReSharp or C++. If you don't have these things, it's because you don't have that extension installed. Same thing with this stuff on the border or the gutter. And that reminds me, this is a great time to put this up on GitHub for you guys so you can follow along just in case I'm coding too fast. So I'm going to put it up on GitHub, I need a couple things to do. I'm going to go to Solution Explorer, right, first. I'm going to right click on my solution and I'm going to go to Add Solution to Source Control. Okay, Add Solution to Source Control. I'm going to use Visual Studio's GitHub link to do everything today. So Add Solution to Source Control, there we go. Okay, it's added. What Add Solution to Source Control does is it does git init, git add dot, git commit -m, and then I think it includes an initial commit for the git ignore file as well as the git attributes file that it creates. Microsoft creates those two things. Okay, and it takes a snapshot of my current this current state of my application. Okay, but it's still not on GitHub. This is just local. I've made a local commit and I want to put it up on GitHub. So the way to do that is to go to Team Explorer. I'm going to go to Changes. You're going to notice that there's no changes here because it just took a snapshot of my files and made my first commit. but I can go to the home button and I can go to sync, and if you have the extension for GitHub installed, then you should have these three options, right? If you don't have this option, it's because if you go to extensions, and if I go to manage extensions up here, then on the online link, you should see this as a check mark, GitHub extension for Visual Studio. If you don't have this, you can search for it, GitHub, just by typing, let's say, Git, right? It'll find all extensions related to Git. The one you want is the first one, and if it's not installed, it'll show up like this, download, right? All of them show up like that if you click on any one of these. And when you download, it will ask you to restart Visual Studio in order for you to install it, and you can do that later. But then you would have the extension. And the extension is really cool because I have to just click publish, and it'll publish out to GitHub. But before we go there, whenever you publish anything or whatever, Git and GitHub need to know who you are. So you're going to go to Home, you're going to go to Settings, and under Global Settings, you want to put in the name of who you are, as well as the name of your email address that is linked to your GitHub account. Okay, this is my email address. So you put yours in there. And then, once you have that configured, you can go to Sync, Publish to GitHub, and when you publish to GitHub, it's going to give you some options. You can choose which provider. You can use GitHub or GitLab or other providers as well. And here I'm going to choose George Brown, right, because this is where we're at today. GAME3001, M2020, Lesson 8, Part 2, Lab 2. That is, my friends, the name of my project that automatically gets populated here. You can change that to whatever you want. And if I click Publish, then it's a one and done process. I've published to GitHub now. And to check this, I can go to the web, and I can put in github.com/George Brown College. And if I look at the top here, it's going to show us Lesson 8, Part 2, Lab 2, all right, which is what I've called it, okay? And you can see clearly that I've got, if I go to SRC folder, and if I look at obstacle, then this is the obstacle class I just created. Okay, pretty straightforward stuff. So you can look here and get that information. Cool, so that is Git and GitHub in a nutshell, right? It's built into Visual Studio 2019, and I'm going to be using that for the semester, just like this. No command line, no other tools like Source Tree or Git Kraken or anything like that required. Everything can be done right through Visual Studio. Okay, great. So I've done this, and I'm going to go to my Solution Explorer now. I'm going to pin that back up. So you can see that I have an obstacle, but I need to place it. And right now the default position is 100, 100. I think it's got to be between, by default, the player and the plane, because I'm going to use the plane as the enemy and the player as my player, right? And if we look at the player right now, let's take a look at that. So if I go to Game Objects, and if I look at the player.cpp, then the player starts off at 400, 300, which is in the exact center of the screen because our screen is 800 by 600, right? So let's move this guy down. So instead of 400 by 300, let's put him at 400 and 500. And then let's put my obstacle at 400 and 300 because I think my plane is at 400 and 200. Yeah, so let's put my obstacle at 400 and 300. So I go back to my obstacle.cpp, and it's going to be at 400 and 300. Okay, so that's where it's going to start, 400 and 300. But I got to add my obstacle to the scene, so I'm going to go into the scene class, which is the playscene.h and playscene.cpp. So playscene.h. I'm going to go down in here and add the obstacle. So I'm going to say that obstacle pointer is m_p obstacle. And it's going to say, hey, do you want to include obstacle resharper. Yes, resharper. Thank you for that help. And then it's going to include the obstacle include for me. I'm going to go to my placing.cpp now. And in my placing.cpp, I'm going to put it where it needs to go, which is inside of my start function at the bottom. So I'm going to say, hey, let's put it together my obstacle texture. That's what it's going to go right here. And it's m_p obstacle. That's equal to a new obstacle. I'm going to allocate some memory for that. I'm also going to use the add child function of my scene class to add the obstacle to the display list. And because it's added to the display list, it's going to be drawn and updated every frame. Okay, that's what's going to happen. So right now, if I just press play, we should have the obstacle in our placing. Let's take a look at that. And again, it's going to take me a minute for me to build because I'm doing a lot of things. I'm running 3 screens on a little laptop. And you're like, little laptop? It's an i9. Yeah, so little laptop. Because the beast that I'm going to be building this semester, which I'm really excited about, by the way, is going to be the latest 10th gen Intel i9. Yes, I am. i9 10900K with 64 gigs of RAM and an RTX 2080 Ti. So I'm looking forward to building that beast. I'm going to use it for, yes, after Alienware. I'm going to build my own. Because I find that it's going to be something that I need more for teaching. I'm joking. It's going to be something that I'm going to use for playing and as well as teaching. It's going to be both things, and I'm also going to be doing other things with it. I think it's a good. It'll be a good general purpose machine is what I'm going to be using it for. I know some people are going to say, why didn't you go with? Why didn't you choose to use AMD parts? AMD is more cost effective. If I went with an AMD Ryzen 9 or something like that. I'll give you the specific stuff. It's not a brand. I'm actually building it myself. So it's going to be parts. Everything's going to be built from scratch, motherboard and all that stuff. I'm just waiting for the new motherboard to come. I've got most of the parts. I'm just missing my RTX 2080, and I'm really thinking about waiting for the RTX 3090s to come out. They're coming out pretty soon. So we'll see if I can hopefully decide one of those things before the end of semester. It might be the beginning of semester or the end of this semester. We'll see how it goes. But I'm going to be building a new beast. So I know, patience. It's a lot of money, but it's going to be worthwhile at the end, I think. Okay, so let's take a look. So we finally built this thing. It took me a few minutes to build. And we have our start scene, and we can go now. We have this little thing here. Look, there's our obstacle, and it's between these two things. So it's a really great test. I'm going to draw a line now between here, and then see if I have line of sight. That's what I want to kind of do, right? Beautiful. So we need to detect line of sight, and we need to draw line of sight so we can see it right now. So let's draw it first this time around. Last time I detected it first, and this time I'm going to draw it. There is a drawing function that I've included for you guys under util. Util.h is a static class, and on the bottom I have several drawing libraries, or sorry, classes that I've included, or map functions. A draw line, a draw rect, draw circle, draw capsule. I've got all those things for you there. I'm going to draw a line between my my player and my plane, and I'm going to use the draw line function to do that. Now, in order for me to use that properly, it has to go in the draw function. Right, that's where it has to go. So if I go to my placing.cpp, I'm going to go to the draw function, and I'm going to call up that util class. I'm going to say util, and yes, I do want to include util. Thank you, resharper C++. I want to, hey util, I want to draw a line between the position of my player and the position of my plane, which is my enemy. Okay, so I'm going to say that m_p player transform dot position, right, and m_p plane sprite transform dot position is where I'm going to draw. So that's where the line is going to go. It's going to be a green line by default. You can make it whatever color you want. This is configurable. By default, I've set it to green, but you can make it so that it's something else. Okay. And if I press play, then we should be able to see a line that's drawn between the player and the plane. No collision right now. Okay, we're going to have to make that function. Cool, start, and you can see that there's a line now that's drawn between the player and the plane. And if I move the player around, the line is going to move between here and there, no matter where I am. So if I'm over here, if I'm over here, it's going to move. So let's just check that, and we'll test that out so it works. So we're going to go to player.cpp, and let's just move the player to the right more. Let's say at 600, not 4600, 600, 500. So if I was to move the player to the right at 600, again, I'm not moving the player with my keyboard and mouse right now. I'm just moving the player by position, just to show you that it can work. Right? One day. There it is. You can see that draws the line no matter where I am to where I'm going, right? So that's kind of what it does. Let's move that back. So I think that was at 400 and 500. This is good. The other thing that's really bugging me is I have to go through the start menu to test my play, my play scene, and I can disable that for now. And the way to do that is, if you're testing a particular scene, you want to go right to that scene. If you go to the singletons, and if you go to game.cpp, and if you scroll down, and it's around start scene, the start scene, it tells you that the current scene is no scene, but I want to change my scene state by default to start scene. Well, you can make this the play scene instead. So we can say that we'll copy paste. We'll copy this one and paste it down here, and we'll comment this one out, and we'll put in play scene. So play scene will start first, this way, as opposed to start scene. Okay. Again, this is just getting you to get things going quicker. Instead of us always going through the play scene, it's going to go always going through the start scene. It's going to go to the play scene right away. It's going to make our development a little bit quicker, right? Which is what we want. Anything is quicker than this, because this is taking forever, right? Again, all these programs open and such. Even though I have lots of memory, it doesn't matter. All right. So that should generate everything that we want. Great. So that is what we want to do, but we also, let me just shut some of these things down. I'm going to shut, I don't need my fireworks anymore. So we can close that window. I'm not going to do any more planning, so we can close this window down. That's also taking some memory and some cycles. I don't care about this anymore. We can close this down, right? Because we've talked about it from a pre-planning perspective. So I can close that down. So I can, again, hopefully that'll make things a little bit quicker than we had before. All right, so yes, this is great. And we've got our line, but there's no check. And the way to do this is to go into managers. And inside of our collision manager, we have a bunch of static checks. One of them is this line check. Line check checks the collision between two lines. And I have a line rect check that checks the collision between a line and a rectangle. I'm probably going to need to do this. And I also have a sample line ABB check, which I go between, before I had a ship and some other game object. I want to make another one. I want to call this check, I want to call it like line of sight check, and I want to check line of sight between two objects. So line of sight check, and I want to include two objects, so they're going to be two display objects. So display object, object 1, and let's call this from. I want to kind of cast a line from one object to another. So, and then game object display object at 2. So I want to go from 2, and I'm going to check to see if I'm colliding with anything in between. So I'm going to have another display object or objects. For now, it's going to be just one, which is going to be some kind of obstacle. Do I collide with an obstacle when I'm checking between my from and to? That's what I'm kind of doing. Okay. Does this make sense? Because basically what I'm saying is, okay, I'm drawing a line from my player to my plane, and I'm saying, do I collide with this object? Am I colliding with this object if I'm drawing a line? This line that I've drawn, is this line that I've drawn between my player and my enemy, does it collide with this object? Now, obviously, I can have more than one object, so I can, instead of using one obstacle, I can send in an array of obstacles, right? For now, I'm just doing it with one, right? That's how we test. We test with one, then we can test with, multiple objects, okay? Or we can use this line of sight check in a loop. It's up to you. So let's implement this. So I'm going to click on this and go here and go to generate implementation, which is going to go inside of the collision manager SVP. And really what I want to do is do this line AABB check. And what I do in the line AABB check is I say, well, here's my line start, and I'm using the object 1's get transform position, and line end, which is object 1's transform position plus, let's say, 100 pixels. Well, I don't want it to be 100 pixels. I want to be the whole line from from where I'm starting to where I'm going. Okay, and then the box that I'm checking is the AABB that I'm colliding with, which is the obstacle. So I want to take all of this stuff pretty much and just modify it. This is coming from line AABB check. Okay. And I'm placing it inside of this. We're just changing some stuff. There is no object 1, it's called from. So we're going to say from, the line start is from the transform position, the from transform position, right? And then the line end is the to transform position. I don't need this part. So from to, right? Line start, line end. Okay, it's pretty straightforward. My AABB is going to be the obstacle that I'm checking. So take the obstacle and tape the obstacle and put it in here. Okay, so that kind of generates the box that I'm checking for the obstacle. So box width, box height, box start, all that stuff is the box. Notice the box start, what's happening is I'm getting the position and I'm subtracting half box width and half box height. Well, that's because my box is centered and I'm marching back half a width and up half a height to get to the top left corner, which is that's what box start is. And then what I want to do is I want to do a line rec check from start to end. And then I want to check where my box starts, right? Which is where my obstacle starts, right? That's what this is. Obstacle start, obstacle width, obstacle height. That's what these things are. And then I'm going to say, okay, take a look at the obstacle. And if the type is obstacle, I don't need to make a sound right now. But if the height is obstacle, let's just do this. And again, I don't have to do this because if it just collides, it's with anything, any obstacle, because it's going to be an obstacle I'm colliding with. But for now, I'm just keeping the same structure, right? Then it's a collision with the obstacle. I could say that, no line of sight, collision with obstacle, all right? That's the C out. Really, I should put this out here, and I don't even need a switch case in this case, right? If I pass this check, I'm colliding. So let's try it out, and I'm going to call this, line of sight check every frame. So let's try this. So I'm going to take this and put it inside of my my placing.cpp. So play scene.cpp, inside of the update, outside of the update display list, I'm going to say that, hey, collision manager, I want to do a line of sight check between my M_P player, I could use this plane sprite too, right, to my M_P plane sprite, and I want to check if the obstacle is in the way. M_P obstacle. I want to see if that obstacle is in the way. If it's true, it's going to print out no line of sight, collision, collision, collision. If it's false, it's not going to do anything. So let's try this out and see if it works. I'm just going to run this now. By the way, if you have questions after this, I really need you to ask me the questions, because this is a key ingredient of your assignment 3 and 4, line of sight. If you can't check line of sight, then your assignment 3 and 4 is going to have some really difficult decisions to make. This is before any kind of decision making or movement or anything. Okay. I'm just going to wait till this comes up. And again, one great place where if you want to make computers that I like to use is PC Part Picker. I think it's a kind of a good site to use. There's other ones out there too. So look, notice that I'm getting, okay, collision, no line of sight, collision with obstacle, and it's true, right? Well, we don't know if we can test this one, but I want to move this guy over here, let's say, and then hopefully we're not going to get any of this, right? Let's see what happens if I was to do that. So again, I'm going to go to the, just by position change, I'm going to go here and I'm going to say, well, this is 400 and 500, which is below. I know that my plane sprite, right? My plane sprite, if I'm not wrong, is like at 400 and 100 or something like that, or 400 and 200. I can't remember. Let's take a look. So if I go to my game objects and I go to my plane, then you can see that the plane is at 400 and 200. So I want to put my player at 200, but I want to put it over on the right, let's say at 600. So if I go player, let's move the player to 600 and 200, which is going to be next to it, right? Then there will be line of sight. I will have line of sight, right? So, and it means that I'm not colliding. So I have to change my algorithm so that it outputs false when I don't have line of sight and true when I do have line of sight, which is opposite of what I've got in there right now. So if I did this, then you can see clearly that I am not blocked and nothing is happening here. So we're good, right? It detects line of sight when I'm behind the obstacle. And again, let's try that again with another value. Let's see, instead of 600 and 200, we'll be lower down. We'll be 600 and 600, kind of at an angle. Let's see what that looks like, right, for this thing. So if you look at that, and if I run it, then we should be pretty good, right? Should be pretty good with that, right? We should see that it crosses through the object. There it is. And you can see now that there's no line of sight. Okay. That's a little bit too low. 600 is probably low. I probably want to put it at 500 max. Okay, so there's no line of sight because it's kind of crossed over there. And that's perfectly fine. That's the way to do it. But our check, our collision manager CPP, right now it returns true if I'm colliding. I don't want to collide. That should be the other way around. This should be false and this should be true, right? And we don't need all of this because it's the obstacle I'm colliding with right now. I don't have to check which obstacle. I don't care which obstacle. Any obstacle, I don't have line of sight, okay? In fact, any object, I don't have line of sight, right? If I was to pass in a group of objects, including other players and so on, if I had another player or whatever, then I wouldn't have line of sight, right? So even dynamic objects. So it doesn't really matter. I can get rid of all this. I can just take this, cut it out, put it in here, right? And get rid of all these checks except for the true, and return false if the check passes, right? If this check passes, then I have no line of sight, and I'm going to return false, right? Because this is a line of sight check. Do I have line of sight? No, false. Or if it fails, then I do. I have line of sight, and that's how it should be. There's your line of sight algorithm, I would say, for very basic. So let's put this up on GitHub. So I'm going to say Solution Explorer, Team Explorer, and I'm going to go to Changes. I'm going to go to Added Line of Sight Check to Collision Manager. Now there's more ways to do it than this way, but this is not a bad way of doing it. Commit all, right? And I'm going to go Home, Sync, and Push. And that is the good workflow for GitHub. I'm able to update a feature. I've added a feature. Home, Sync, Push. And I keep doing that over and over again. I do a commit. I go to Home. I go to Changes. I do my commit when there is one to do. And then I go to Home, Sync, and Push, and I'm good to go. And it puts everything up to GitHub. And that's the process, guys. You can watch the video if you need to refer to this as a way of putting it up to GitHub. Now, this is me working alone. If I was working with another group, then my workflow would be different. If I'm working with a bunch of people, then maybe what I would have to do is make my own branch and then, do a pull request. That's one way of doing it. I could also do things like a merge or something else. Right now, I'm not doing that. I'm just working on my own. Okay, so this is line of sight check done. But, it would be nice if we can move our player around so we can dynamically check that this is working. And I also want to enable, kind of our debug to work when I press different keys, right? So if I go back to my scene, I'm just going to close all these down now because I think I've accomplished part of what I wanted to do today. So close all documents. And I want to go to my Solution Explorer. I want to go to my scenes, and I want to look at my playscene.cpp. You notice that the way the event manager works, here's the event manager. Again, I use the big long names. I know Alex kills these and makes them smaller. Like for the collision manager, he calls it coma. For the event manager, he probably calls it EMA or something else. I don't know what he calls it, but or EVMA, I don't know. But EVMA, there we go. Coma, EVMA, Mama. That's pretty funny. Each one of these things, it's the same. It doesn't matter whether you rename these or not. You can make aliases for all these things. It's not a big deal. But here in the event manager, you can see that I'm getting a get game controller here, right? So get game controller. That's what I've called it. And I can also do things like in the game controller itself, I can set the animation state and all that stuff. So what's happening here is if I get the left stick on the X, if it's greater than the dead zone, then in here I already have a way of moving to the right and left. And then I'm duplicating this as an example if I don't have any game controllers as an example, and I have I want to move with key downs, right? So if my key down is scan code A or scan code D, then I can move left and right, and then up and down. I really don't have an up and down right now. I can only move left and right, okay? So I want to at least be able to move my object left and right. And the way to do this is to add velocity. So if I go to my player, so if I go to my game objects, and if I look at my player.cpp, right, remember that every frame I have a draw function, okay? And my draw function gets placed, my draw position is wherever my position is. So this is where it gets placed, based on my position only, okay? So there is no calculation for a move, right? I haven't implemented this, right? So for us to make it work, we'd have to say that get transform position, and you want to add in the rigid body velocity to this thing. whatever the velocity is, times the speed, is what you want, right? So whatever the speed is. And if you notice, inside of our game object superclass, so if I go to game objects, game object, under game object, I have a series of different properties that we can use, right? So one thing that I have is definitely, like we talked about before, I have a transform and I have a rigid body. I have a width and a height, right? And all these kinds of things, right? And what I want to do for my player is, I don't have a speed. If I want to define what rigid body is, just let's look at what that is. Go to definition. Rigid body is a struct, and right now it has a few things: mass, velocity, acceleration, and is colliding, right? One thing it doesn't keep track of is speed. So not velocity necessarily. That's a physics velocity, but a speed scalar. So not a vector, but a speed, max speed, if you will, which is something that I can add into my rigid body, right? I can add it anywhere else I want to, but I can set my max speed to whatever, and I can house it in something like a rigid body, and that's perfectly fine, like a floating mass equivalent. So let's do that. So in my rigid body, I can go float, and I'll call this max speed. Okay, so there's my max speed. So all objects can have a maximum speed. That's what this thing is, right? And my maximum speed will be something that I can say that this is the maximum speed, almost like a speed limiter is what's happening here. I could also have a minimum speed. I could also have a current speed and all that kind of stuff. Speed is, again, distance per, kind of the amount of distance per second, as an example. A velocity is distance per second, but it's also in a specific direction. So that's the difference between speed and velocity. And we're going to talk about this next semester in physics, right? So maximum speed is like a speed cap, right? How fast can something move? And what I need to know is what's my current speed. So if I have my current speed, if you will, is the thing that's going to make me, I'm going to multiply this by my velocity, and we're going to get a speed factor. Now I could also just attach my velocity. I could attach a number to my velocity and then add it on to my position every frame. That's okay too. But I want to use max speed as kind of a limiter for now. Okay. One thing to note is in my GameObject.cpp, I don't initialize everything, right? So I go through it and I go, okay, I want a new rigid body and all this kind of stuff. And when I get a brand new rigid body in my game object, notice that I'm not initializing my, I can set and get my rigid body. That's one thing I can do, okay? But I don't initialize it here. If I go to my display object, I also don't do it here. I don't sit there and go, okay, let's initialize my rigid body or my transform or anything else. I do it usually inside of the game object itself. So if I go to game objects, and if I look at something like my ship.cpp, then you can see that in here I'm saying, here's my position, here's my velocity, here's my acceleration. I can kind of indicate how fast it's moving or whatever, and I can add my velocity, and here's my current heading, my current direction, my turn rate, all that kind of stuff that I can have in my ship if I want to. And that's the thing that I want to do. Here's max speed, right? I've set max speed for my ship to 10, right? And then what I can do, and this is just an example of a ship, when I'm moving forward, I take my current velocity multiplied by, or is equal to my current direction, so the way where I'm heading, and I multiply that by max speed, and that's my move forward. Move back, I take my current velocity, and then is equal to my current direction, whatever that is, and then subtract max speed if I'm moving backwards. And when I move, the ship's move thing, I take my position, and then I add my rigid body velocity, right? And then what I'm doing is I'm doing some smoothing, where I say my current velocity is my velocity times 0.9, so it's going to slow down eventually. This kind of thing. So I want to do the same thing, right, with my player. So there's my player. But I want to kind of define a couple of things. I'm not going to define velocity as a thing. Notice that in my ship, I'm saying that there is a default velocity. My default velocity is 0, right? Just like it is for my player. Okay, here's my default velocity. And I got to be careful, because really what I'm saying is make it 1 when I'm moving to the right, you know, and then multiply it by whatever the speed is. That's what I want to do. I want to do kind of a maximum speed. One thing I definitely want to set for my player is the maximum speed. So I want to say, hey, rigid body, let's set the maximum speed to something. So get rigid body, and then I want to set maximum speed, and that's going to be a floating point number that I'm going to set to something. So let's say, for example, 10. I'm not sure if that's going to be the right number, but 10 would be the good number to start with. All right, and in my move function, I don't really have a move function. I don't have that. But basically, my position, my draw function is my move function right now, because my draw function is going to draw it in the position that it's going to be, right? And what I'm doing is I'm going to take my position, and I'm going to set my position. I'm going to add my velocity. So there's two things I could do. I could add in a move function that changes my my position. That's what it does every single frame. And then I'm just going to draw my position. And I think that might be the right way to do it. In order for me to make a move function, I need to add it in the .h file. So solution, I'm going to go to my player .h, and we're going to add a new function, which is the move function. So I'm going to say it's going to return void. Okay, there's my move function. And this move function I'm going to define. So I'm going to go to definition. Sorry, I'm going to define it, implement, define this thing. So let's see if I can do it right by just clicking this button and going generate implementation. I'll be okay. And then what I want to say is when I'm moving, depending on where I'm moving, the direction that I'm moving in, right? If I'm moving to the right, then I'm going to change my maximum speed, multiply something to my maximum speed to the right or left. All I want to just move right and left right now. I don't want to move up and down, right? Because that's all I can do with my Mega Man, move right and left, right? So if I move right and left, I need to kind of define how to do that, right? One thing I could also do is I can modify, here, let's do this just because we're running out of time. I would normally do it in a more complex way, but just because we're running out of time, I'm just going to do it a different way today. And we'll fix this next week. So what we'll say is in my placing.cpp, I'm going to take my player, so when I move to the right or move to the left, here's move to the right, move to the left. And I'm going to say that when I move to the right, I'm going to say that m_p player, and then I'm going to set, actually I'm going to get my rigid body, and I'm going to, my velocity, right, is going to be equal to something else. So velocity is going to be equal to a new GLM vec2 object, which I'm going to say that it's going to move to the right. So or to the right is going to be on the x-axis 1.0f, and then 0.0 on the y-axis, right? This is this. And I'm going to say that we're going to multiply that by m_p player, and then get rigid body max speed, whatever that max speed is. We're going to multiply the this thing here, and we're going to do that because I'm going to define it as a new velocity. We'll say like we'll call this auto new velocity is equal to, and we'll just go do one of these. Actually, I can do it in one. I can just do it without the new keyword. Yeah. There we go. So this changes my velocity, and then what I can say is I can take my current position and add my velocity every frame, right? So I think that's what I want to do. I'm going to add my velocity every time. So M_P player, and I'll say that get transform position, and I go plus equals to M_P player, and then I'll get rigid body velocity. All right, so whatever, I calculate my velocity, I do this, and then I go to the right, and then what I want to do is every frame I want to say that my velocity is equal to my velocity times equals to my velocity times 0.99 f. So it's going to, actually I'll make it 0.9 f. So it'll slow down basically every frame. Okay, so let's try this. Let's try, and this is with the game controller only, and let's see if that works for my game. I'm going to run out of time because this is kind of what I want to do for each of the players' movement things. But I think you get the kind of idea. I think we've kind of accomplished our goal, and what I want to do right now is I want to make sure that we can kind of make it go to the right, which is what's going to happen with my game controller. Let's see what happens when this thing finally compresses. And these guys are aching to build to do D&D tonight. We're going to do D&D later on. Okay, let's see. Looks like around 6:37. All right. Yeah, this takes all kinds of time to build, and again, it's because of all the stuff I'm doing. I'm pretty sure, because normally it's like build in no time, but this is not the case now. And yeah. All right. So again, it's supposed to slow down, and I've got my controller. It should say controller detected. Right, so, and if I do it, I should be able to move to the right or left, right? So it looks like I'm not moving right now, right? So, I mean, it is detecting, it's just moving way too slow, probably, for it to do anything, right? So let's try one more time. Let's muck with the values just to get a little bit of movement. Let's just get rid of this. And, and I'm multiplying it by, I'm saying that it's equal to 1 multiplied by the max speed. My max speed is 10. Let's just say that the velocity, I'm going to add velocity to my position. So let's give it a velocity of 10 for now, and just do it right in there and not slow it down, and see what happens. So what happens when you do all the testing? I'm going to make sure that things are working properly too, right, for this thing. So again, it's like a, oh yeah, of course it's not going to work. Ha ha ha. I've entered it in the wrong space. Let's try it with my D key. D, right? Yes. And it doesn't do both. That's the problem. And that's one thing I haven't put in. So we'll take this code and we'll also put it in my controller to the right, which is this part for now. Right? There we go. And let's try that again. Yeah, because when I plug in my controller, then my keys don't work. And when I plug, I have to kind of make both work at the same time. Because it makes sense. If I'm having a controller, then why would I use the keys? And Are we cooking? Yes, we are. And it kind of, okay, that's good. That's actually really good. So notice that the obstacle failed. It's not colliding anymore. So I want to do the same thing. Let's add back that reduction in speed, and let's try it again. And then we'll be done for the day. Let's move it back and forth. I just want to show that it moves back and forth, and then I can reduce I can take away the line of sight. Check. Good. All right, so that works well, and you can see that it's not going crazy anymore, and we can make it go crazy. So let's do the other way. We'll say that this is good, but to make it really simple, we're just going to copy paste in here in the left stick, and instead of it being positive, we'll make it go negative by 10, and we'll do the same thing, form a scan code left, so we can go left with either the keys or the controller. Right now I'm using the controller. So see how that looks. Okay, so we can get pretty good on what we're doing here. So again, you can see that he kind of floats a little bit too much, but notice that this is the key to look at. Look over here. So he's colliding, and then not colliding, and then colliding, and not colliding. So you can see that that line that's being drawn is literally, he can avoid obstacles. So here I have line of sight, but as soon as I kind of go here, you can see that it kind of creates that collision detection. So that's pretty good. Okay. And that's what I kind of wanted to show. I think he moves a little bit too quick for Mega Man. That's just me, right? Probably 10 is the wrong value. He floats a little bit. He skates. He's skating on ice right now, but that's just me. So maybe a value that's smaller instead of 10, and then we'll end for the day. Just for this, we'll make it half as fast. We'll make it 5. And again, this is just for us to practice with. We need a better move method, I would say, that we have to implement, right? So that it looks nice and feels nice. Okay, and let's try this out one more time. And I haven't even added in the up and down movement, which is pretty simple, right? I mean, literally, it's just up and down. The only thing is that I don't have an animation that shows him, kind of jumping in a way. So it's not a great, sprite. I'd have to replace him with something else. And I will next week. We'll have something different than Mega Man. Okay, but again, you can see that he's colliding. I think it's still too fast, but now he's not, and you can see that that's not happening as well. No collision, right? That's pretty good. And it's pretty dynamic. I mean, you can see like the line, it's like almost instant, right? And if I unplug this guy, so let's try it without the controller. Let's try it with the keyboard. So I take the controller away, and the controller's been disconnected now. Now it should work with the keyboard just the same. So here's the keyboard. You can see that that's working there. That's pretty good. It's pretty smooth too, right? So no collision, right? All right, and that's what I wanted to show you today. I think that's good enough for today. I'm going to put this up on GitHub, and we'll talk about what we did. So added right and left movements, just as a test. So we'll say commit all, again home, sync, and push. Okay, questions around this stuff. Again, I think it's pretty straightforward what we did. We set up line of sight. Now that we have line of sight, we can detect it. And the way we're doing it right now is I'm printing it out. But really what I can do is I can turn on a flag and turn off the flag. Do I have line of sight? Yes or no? And I'm doing it on the player, but it can be done simply on the enemy, where the enemy has line of sight or doesn't. A node, it has line of sight or doesn't. All that kind of stuff can be done by just the things that we've already put together. Okay. That's it for me today, guys. Thank you so much. Next week, we're going to do a lab in class. So be prepared to do a lab where you're going to have to submit something by the end of class. And again, why? Because we're building up some stuff. Right now, there's not really a lot to build up for you guys to hand in. But next week, there's going to be something more, almost like a little piece of what I'm asking you to do to hand in. And I'll have more content for you guys so that you can test with other assets as opposed to the assets that I have here, which was Mega Man and the little ship. Will make it so that we're going to build up part of your assignment by next week, and then you'll complete it with you and potentially a partner. Okay? Otherwise, I'm going to stop recording now. If you have a question, I'll wait around for any kind of questions you may have.